So, we just finished multiplication. Now we're going to move on to division. Okay? To the quotient property of radicals. Okay? It's very similar to the product property of radicals. When you have the division problem of two radicals, you can change it into a division problem of one radical, or a radical of a division problem. Okay? So again, two radicals that we're dividing, we'll make it one radical of a division problem. Okay? So let's use that in this example right here. Okay? I'm going to let you know one thing right now. You should get, anytime you see a radical in the denominator, you should get a red flag. Okay? Anytime we see this, we don't like this. So there's two ways to go about it to get rid of that radical in the denominator. Okay? The first way is what we're going to do right now. Okay? So we have square root of 5, 45, square root of 5. The thing we want to know is, can we divide these two? Do we know if we can divide these two? Well, we know, yes, we can. Okay? We know 45 can be divided by 5. So we want to be able to do that by switching it from two radicals to one. Okay? So I'm going to take this and to make it one large radical. Okay? Now we can do that division problem. Now we can do 45 divided by 5. Well, 45 divided by 5 is equal to 9. So we have the square root of 9. And then we go back to our simplifying process. Can I simplify the square root of 9? Well, you bet. 9 is a perfect square. Its square root is 3. Okay? So that's one way that we can get rid of this radical in the denominator. Okay? Moving on. Well, now we have a division problem inside the radical. Okay, well, can we divide 24 by 10 and get a nice even number? No, we would get 2.4, and we don't want decimals. Okay, well, what's nice about the quotient property, just like the product property, is you can go in kind of a circular motion, circular method. Okay, so if I have the square root of 24 times 10, I can break it down into two radicals. It can become square root of 24 over the square root of 10. Okay? Well, a lot of you are thinking, well, Mr. Smith, you just said we can't have a radical in the denominator. That's correct. But when it's in this form and you can't divide it, this really means you have a radical in the denominator, just like it says here. Okay? So we want to try to cancel out this square root of 10. Well, if you remember back to a couple problems ago when we had the square root of 6 times the square root of 6, what did we get for our answer? We got 6. So we're going to do that same process. The way to cancel out the square root of 10 is to multiply it by the square root of 10. And if you remember about fractions, what you do to the bottom, you must do to the top. I need to take the top times the square root of 10. Okay? Well, we happen to get this. We multiply fractions, we multiply straight across. Square root of 10 times square root of 10, what did we say was? 10. Okay, because if we actually multiply these, we would get the square root of 100. It was a perfect square. Its square root is 10. Okay? So again, that's why we get that. And then up top here, we have the square root of 24 times the square root of 10. Well, this just goes back to the product property of radicals. First, we look to simplify. Is 24 a perfect square? No. Can it be broken down by a perfect square? You bet. Is 10 a perfect square? No. Can it be broken down by a perfect square? No. So that's why 10 has to stay for now. So we have the square root of 10. Well, Square root of 24 can be broken down into 4 times square root of 6. 10, which then we can break down to 2 times the square root of 60. I've jumped a step. I've already multiplied these two together since I can't break them down. Okay? This is all over 10. Well, now I look at square root of 60. Is there any perfect squares that go into that? Start with the closest. 49? No. 36? No. 25? No. 16? No. 9? No. 4? Yes. That's what I have. So this guy right here breaks down into the square root of 4 times the square root of 15, which breaks down into 2 times the square root of 15. Okay? Well, I can combine my outsides. I'm going to move this over here. It's going to be 4 times the square root of 15 over 10. Okay? And there's one more simplification we can do. Again, we look at the numbers on the outside, because those who we can manipulate together. Well, if you hit that square root of 15, you would see 4 over 10. Well, that's a fraction we can simplify down into 2/5. So our final answer, I'm going to do in blue, is 2 radical 15 over 5. Okay? And you can't change this 15 and 5 because this isn't a radical, this isn't. Okay? So there's a lot going on right there. It may help for you to go back and rework this problem. Okay? Before you move on to your turn. Okay? So, when you're ready to work on these problems, go ahead. If you have a question about what happened in that last process, don't be afraid to ask. Okay? Make sure you understand what's going on. Okay? So, when you are ready, please press the pause button. When you're done, we'll go through the answers. Okay, so you just finished these problems. Let's go through these. Well, I have a radical in the denominator. That means red flag. So my first option is, can I divide the denominator and the numerator since they both have the same radicals? You bet. 24 can be divided by 3. I need to change it to one larger radical, which is 24 divided by 3. Well, 24 divided by 3 is 8. We're not done. We gotta still see if we can simplify. 8 is not a perfect square, but a perfect square can go to an 8. Square root of 4 times square root of 2 would equal the square root of 8. We can take the square root of 4 to get 2 times square root of 2. Okay. This next problem, okay, well, can we divide 75 by 6 and get a whole number? No, we can't. So we got to change it into 2 radicals. So we have the square root of 75 over the square root of 6. If you remember, you can't have a radical in the denominator. Red flag should be popping up. Okay? So we got to multiply it by the square root of 6. That's how we cancel out the bottom. That's how we get rid of that square root. Okay? Well, we know that the bottom is going to be equal to 6. We know that we're going to be multiplying the top. So can we simplify anything up top there? Well, let's see about 75. It's not a perfect square. But does a perfect square go into 75? Well, we have 64 does not, 49 does not, 36 does not, 25 does. So I'm going to go up here with this work. Square root of 75 is equal to the square root of 25 times the square root of 3. We know, though, that we can take the square root of 25 and get 5. And we cannot take simplified square root of 3. So that's what our answer is going to be. Apologize, the lights. So now we have on this in the numerator 5 times the square root of 3 times the square root of 6. Okay? Again, we can only combine outside numbers with each other and radicals with each other. So square root of 3 times the square root of 6 is equal to the square root of 18. This is over 6. Okay? Now we got to see, can I simplify that radical anymore? 18 is not a perfect square, but 9 is, and it goes into 18. Okay? So we'll move this over here. I'll use another color so we're not getting all befuddled. Square root of 18 is equal to square root of 9 times square root of 2 is equal to 3 times square root of 2. Okay? So I know I can combine my outside numbers together. 5 times 3 is 15 times the square root of 2 over 6. We're so close to our final answer. The last thing we want to look at, I know I can't simplify the radical, but can I simplify the fraction of the outside numbers? 15 and 6 both have the number 3 in common. So if I simplify those, I get 5 times the square root of 2 over 2. Okay? A lot of information today. Please feel free to go back, rewind, go over parts again. Make sure that you're getting these steps down correctly. If you have questions on about how I went from one area to the next, raise your hand and I will be around to answer that question. Okay? If you feel like you are ready to take on the homework, please raise your hand and I will get that worksheet to you. Thank you.